Let's talk about one of the biggest challenges we're facing right now. How do we actually control who gets access to powerful AI systems? Because as this tech gets woven into everything we do, making sure it's used safely isn't just a tech problem anymore. It's about security, it's about trust, and the secret to getting it right might just be hiding in plain sight, in a single sentence from a technical guide. Let's check it out.
Okay, so this is it. Everything we're going to talk about today starts right here, with this one seemingly simple objective. It lays out 4 different layers of access control: model, data, agent, and API. Now, these aren't just buzzwords. Think of them as the 4 foundational pillars of AI security. And understanding them, it's not just a good idea. It is absolutely essential if we're going to build an AI future that we can actually trust. So, let's break them down one by one.
So here's our game plan. We're going to start by looking at the big picture with a metaphor I really like: the AI as a digital fortress. Then we'll dive deep into each of those 4 locks we just saw: the model, the data, the agents, and the API. And finally, we'll put it all together to see how they form a single, layered defense.
I want you to get this picture in your head. Stop thinking about AI as just a piece of software. Instead, picture it as a digital fortress, and inside this fortress are some incredibly valuable assets. Now, just like a real castle, you wouldn't just lock the front gate and call it a day, would you? Of course not. You'd have guards on the walls, vaults for the treasure, and strict rules for who can go where. The exact same logic applies here.
So, let's start at the very heart of our fortress, the model itself. This is the core algorithm, the brain of the whole operation. It represents thousands of hours of research, a ton of money, and a whole lot of brain power. Put simply, these are the crown jewels, and they need to be protected above all else.
So when we talk about model access, we're really asking a few critical questions. First, who gets to use the model to get answers? Second, who has the keys to go under the hood and modify how it's built? And third, and this is a big one, who is allowed to retrain it, to teach it new things? Each of those actions carries a totally different level of risk.
And let's be clear, this is not just some theoretical exercise. The consequences of getting this wrong are very, very real. They go way beyond your system just crashing. What actually happens when the brain of your AI is left wide open for anyone to mess with? Now, check this out, because the threats here kind of level up in severity. At the most basic level, someone could just steal your model. That's your intellectual property, worth millions, walking right out the door. Or they could copy it and launch a competitor. But then it gets way worse. A bad actor could secretly retrain your model with poisoned data, twisting it to produce biased or just plain wrong results. The nightmare scenario, though? They get in and manipulate the algorithm itself, maybe creating a hidden backdoor to control it. That's scary stuff.
Okay, so we've put a guard on the crown jewels. But a brain is useless without knowledge, right? For an AI, that knowledge comes from its data. I want you to think of the training data as the AI's entire library. Every single book it's ever read to learn how the world works. Protecting this library is our second critical line of defense.
Data access, then, is all about playing the role of the ultimate librarian. You're controlling the flow of information. Who's allowed to see the sensitive data the AI learned from? Who has permission to add new books, new data to the collection? And just as important, who can go in and change or even delete the books that are already on the shelves?
And this right here is the golden rule. It does not matter how sophisticated or brilliant your AI model is. If the information it learns from is corrupted, biased, or just plain wrong, the AI will be too. You know the old saying, garbage in, garbage out? Well, with AI, that's magnified 1,000 times. The system's integrity is completely dependent on its data's integrity.
So let's really think about that for a second. What are the real-world impacts? If a banking AI is fed biased loan data, it's going to make biased decisions. It's that simple. If a medical AI is trained on flawed patient records, it could make a life-or-death misdiagnosis. Compromised data doesn't just create a buggy AI, it can create a genuinely dangerous one.
Let's move on to our third lock. So far, we've protected the AI's brain and its library. But modern AIs don't just sit around and think. They do things. They take action in the world. And these actions are carried out by what we call agents. So if the model is the brain, then the agents are the AI's hands.
Agent access is all about permissions. It's not about what the AI knows, it's about what it's allowed to do. Can it send an email? Can it buy something with a credit card? Can it execute a stock trade? Can it access other computers on the network?
This control layer defines the sandbox the AI gets to play in. It sets the boundaries of its power.
And this is where things can go from bad to catastrophic really fast. Imagine an AI designed to optimize a company's cloud spending. If its agent access is unchecked, a simple bug could cause it to start deleting critical servers, costing millions. Or a customer service AI could be tricked into issuing unauthorized refunds all day long. Controlling the AI's ability to act is absolutely vital.
All right, we've made it to the fourth and final lock. We've secured all the assets inside our fortress. But how does the outside world interact with it? That happens through the API, the Application Programming Interface. You can think of the API as the main gate, the one controlled entry point to the entire system.
So, API access is all about managing the traffic that comes through that main gate. It's like having a digital bouncer. It decides who's allowed to send requests to the AI, what kinds of requests they can make, how often they can make them, and what info they get in return. It's the traffic cop for your AI.
And this is the perfect way to think about it. The API is literally the digital front door to your AI. It doesn't matter how secure the rest of the house is if you just leave the front door unlocked. A poorly secured API is an open invitation for unauthorized use, data breaches, or attacks that could bring the whole system down. It's your first and often most important line of defense.
So, we have our 4 locks: model, data, agent, and API. And the biggest takeaway here is that these aren't 4 separate things you can just check off a list. They are interlocking pieces of a single, comprehensive security strategy. You really need all of them working together.
This table sums up our fortress metaphor perfectly. You need to control access to the AI's brain, which is the model. You have to protect its library of knowledge, the data. You need to manage its ability to act with its hands, the agents, and you have to secure the gates through which the world talks to it, and that's the API. Each one protects a unique and vital part of the whole system.
So here's the bottom line. A truly secure AI system demands what we call a defense-in-depth approach. You can't just focus on one thing. You absolutely must protect the core algorithm, secure the data it uses, constrain its actions, and lock down its front door. A failure in any one of these areas can compromise the entire fortress.
And that brings us to one final big question to think about. Looking ahead, as AIs become more and more autonomous, more capable of acting on their own, which of these 4 locks do you think will be the most critical to get right? Is it protecting the model from manipulation? Is it ensuring the data stays pure, securing the API gate? Or, as AIs gain more agency, will controlling their hands, their ability to act, become the single most important challenge we face? The answer to that is going to shape our future.